because velocity is going to be 0. Okay, now have you revised all these things? Yeah, okay. So let us go with the next condition, which is important to us. That is, when the what is that? This bob will leave the circular path. Let us see. If you see here, suppose if I have given some velocity, it is oscillating. See once. If I give little velocity, it is oscillating. Okay, na? So this is the one point, this is the one extreme point, and this is the other extreme point. See. So here velocity will be 0. Here also velocity will be 0. It is coming to rest. Whatever I explained. Whatever I explained. So these are the extreme position. You are able to see na this pendulum. This what is it? That steel ball, spherical ball is, we call it as what? We call it as bob. So bob will oscillate in this way. So in the entire journey, tension won't be 0. Tension is, in the entire journey, the tension value is greater than 0 only. You'll get some tension value. Okay. But see, here it will have some velocity. At the bottommost point, it will have some velocity. As it is going up, velocity decreases because height value is increasing. No, as it is going up, the height value is increasing. Then obviously speed value will decrease because of gravity, because gravity is acting downward. It's something like a vertically projected body. Sorry. Okay, na? So because of gravity, what happens? Its speed value will decrease. So this particular thing we call it as what? Oscillation. It is called as oscillation. So when oscillation will happen, whenever you have given little velocity, if you give little push at the bottom, then it will oscillate. So if you give little more than velocity, more than this velocity, if you give more velocity, then you can see here. Suppose if I give more velocity here, little more than previous, if I hit, then it will go and reach the 90 position, which is horizontal position, and will reach to some position. Somewhere tension will be 0, then string will become loose. If tension is 0 means there is no stiffness in the string. So string will become loose. Then it will leave the circular path. Okay, na? So what is the case? It is leaving the circular path. So when it will leave the circular path, tension value should be equal to 0. All of you are able to see now how string will slack. It's called as string slacks. Okay, it's called as string slacking, or a simple tight and loose. Okay, so string will become loose, you can say. So this happens when you give velocity more than the previous one, okay, understood? So under this condition, tension will be 0, but velocity won't be 0. Okay, na? So observe this one clearly, because on this you will get very good questions and little tough questions also. Okay, na? So where it is leaving the circular path, it is leaving the circular path here. This is the point. This is the point where it is leaving the circular path, but it is having the velocity. So it is following some trajectory. Okay, na? So at this instant, what I can write down? At this instant, tension value is equal to 0, but velocity is not equal to 0. Speed won't be 0, but tension is becoming 0. Getting this one? All of you getting this idea? Speed is not becoming 0, but tension is becoming 0. So what I can write down? I can write down that. We can make a note, pendulum will leave the circular path. Understood? When? What is the condition? For leaving the circular path, what is the condition? When tension becomes 0. Whenever tension is becoming 0, there is no tension acting. As there is no tension acting, so there is no what is that agent which will make the bob to rotate in circular path. See, it is going in circular path because of what? Because of string only. If tension is 0, that means string is loose, means string is not doing anything. Then bob won't go in circular path. Bob will go under gravity. It's something like a just projected body, and projected body is moving under gravity. So it will go in a curved path. You can see curved path, because only gravitational force will act on the bob. Okay, no? Because tension is not acting. So it can go in a circular path whenever string is in work. What is the meaning of string is in work? String is in work means string has to apply some tension. Okay. So when tension becomes 0 before velocity does. So I wrote in my words. What is the meaning? When tension becomes 0 before velocity does, means before velocity becoming 0, tension has to be 0. Then it will leave the circular path. So here tension is becoming 0, but not velocity. Velocity is there. Okay, na? So this is the velocity direction. Because of that velocity direction, it is going in a curved path. It is going in a curved path. You can say parabolic path. You can say the projectile path. So this path is simply, you can call it as, or you can write down as what? This path is projectile path. Why? Why it is called as projectile path? Because it has velocity. It's like something like a projected at some point on the ground. Then it will go in a projectile path. No tension acting. See, in this entire journey, string is loose. String is loose. See once. Observe carefully. Observe carefully this one. This is the pendulum. Pendulum is having the velocity. Okay, na? So tension is 0. It will leave the circular path. Now string is loose, no tension acting. Then what is the force acting? Only mg is the force acting. Here velocity is there. Everywhere mg is the only force acting. So if you project a body here, you can project anywhere. No, projectile means no need to project from the ground only. We discussed in kinematics theory that we have oblique projectile, okay, vertically projected body, and oblique projectile from a height also. You can project from anywhere. You project a body from here and only gravity is acting, then it will go in a projectile path. Okay, na? So once it is leaving the circular path, the particle or bob will follow the projectile path. Okay, na? So that is also important point. This is the one important point. Second one is after leaving the circular path. After leaving circular path, so how the bob will travel? The bob will travel in projectile path, okay, and can be treated as projectile also. You can write down if you want. You can add one more thing. Can be treated as, you can treat that one as what? Projectile or oblique projectile. You can write down anyway, no problem. All of you understood? This is called as leaving the circular path. So for some velocity, if you are giving the different velocity, so there is a chance for leaving the circular path also. There is a chance for oscillation also. According to whatever velocity we are giving, okay, so there is a chance for oscillation, there is a chance for leaving the circular path. All of you understood? Any doubt, let me know, I'll explain. Don't worry. And you can copy this one. Okay, na? You can copy the diagram and string. String and diagram you copy. So of course you cannot show that motion of the bob. Okay, copying. All of you switch on your videos and follow carefully all the things. So I think you understood the condition for oscillation. So what is the condition for oscillation? Condition for oscillation is velocity should be 0 but not tension. Velocity should be 0. Then only it will come back and oscillate. What is the condition for leaving the circular path? For leaving the circular path, condition is what? Tension should be 0 but not velocity. Reverse. Okay. Tension is 0 but not velocity. That is the condition for what? Leaving the circular path. Of course, Lokesh Reddy. Perfect. Total distance traveled. Yes, you can say. Because it is leaving the circular path, no, it will become parabolic. So usually that distance of parabola should be less than the circular. Okay. So we can say no issue. Okay, na? Finished? Wrote down? So I think some people are there in the school also. So let us see what is the condition for completing the vertical circle. Okay, na? Condition for completing vertical circle. Okay, what is the meaning of condition for completing the vertical circle? Let us see. So now I'm taking the one pendulum of length L, and there is a bob of mass M. Now I'm giving the velocity u at the bottommost point. At the bottommost point I'm giving the velocity u. I'm projecting. I'm projecting and leaving. Okay, na? Just I projected and left. So then what happens? It will go. So it can oscillate according to u value. If u value is very small, it will oscillate. If u value is little more, it will go to some place and leave the circular path. But condition for completing the vertical circle, what does mean? So now it has to complete the vertical circle, means it has to rotate in a complete circle. It has to rotate in a complete circle. Whatever I shown previously. Previously I've shown, no, when you hit the pendulum will complete the vertical circle. Okay, na? Then, so for completing the vertical circle, the bob has to go in this way. Now there is no, there is no place where tension is zero. Suppose at some place tension is zero, then it will leave the circular path. Means tension should not be zero from here to here. Am I right? If tension is zero here, what happens? Tension is zero. Then it will leave the circular path. It won't complete the circular path. So in this entire journey, rightward half of the circle, you can take this is complete circle. This is the rightward half of the circle. So in this rightward half of the circle, at all these points, tension should not be equal to zero. Am I right? So that means it will reach the highest point with some velocity v. So velocity should not be zero. If velocity is zero, then it will fall down. Okay, na? Velocity should not be zero. It should have velocity. So v value should not be zero. There should be some velocity. Otherwise, what will happen? The pendulum will fall down. Okay, because if it is velocity zero, if velocity is zero, gravity will act. String tension is also acting downward. Let us say tension is acting. Then it will fall down. Then string will become loose. Means leaving the circular path only. It's something like a leaving the circular path concept. So v value should not be zero first of all. Okay, na? Once it is crossing this point, then automatically it will go in a circle and come back. Because it is downward journey, no? Downward journey is easy than upward journey. Upward journey means against the gravity. Now it is under gravity. Understood? So what is our critical point? What is the critical point to complete the vertical circle? The critical point to complete the vertical circle is highest point. Means we have to project in such a way that it has to pass through this point. All of you getting my point? See, actually for next 15-20 minutes, you will have a little theory you have to follow carefully. Okay, na? So then only you can solve the vertical circular motion easily. All of you getting this idea? We are giving the velocity in such a way that we have to give the velocity in such a way that this pendulum has to reach the topmost point. This is the topmost point. Okay, na? So once it is crossing the topmost point, automatically it will come down. Clear? Logic understood? So that's why topmost point is of our critical point. We are saying that this is a critical point. In every journey there is some critical point, no? Okay, so if you cross that critical point, you will feel it's something like a relaxing feeling after crossing the critical position, something like that. So this is the critical point where pendulum has to cross this point. Once it is crossing, then no need to see that, it will complete the circle. All of you agree? And moreover, to pass this point and this journey, in this journey, tension value should not be zero. So hope you understood this idea. Okay, na? So let us go with the equations now. So it is having the velocity u here, L, and obviously this also L. Then what is the distance between the lowest point and highest point? 2L. So now L will be the radius. L will be the radius of the circular path. Okay, na? So this is the u velocity and this is the v velocity. Okay, and here some tension is acting T, and mg also act downward. Then what is the total force acting towards the center? Centripetal force I'm writing, because obviously we are talking about circular motion, so centripetal force idea should be applied. So by centripetal force idea, what I can write down? I can write down that total force acting towards the center, T plus mg, should be equal to mv square by, what is the radius? Radius is L. Okay, na? That is the tension. Now tell me what happens to the velocity. At the bottom we are giving the u velocity. As it is going up, what happens to velocity? Decreases, speed decreases because of gravity. Because of gravity, work done by gravity. Work done by gravity is negative, so kinetic energy has to decrease. Work done by tension is zero. Tension is always perpendicular to the path. Tension is something like a radial force, which is acting along the radial centripetal logic. Okay, na? So work done by tension is always zero. So that's why no need to take the work done by tension. But who will do the work? Gravity will do the work. What work it will do? The pendulum is going up. Gravity will act downward. So gravity will do the negative work. Because of negative work, what happens? Kinetic energy decreases. Or else, very simple, common sense you can use that as the body is going up under gravity, what happens to speed? Speed decreases. Okay, got it clear? So then what is the relation between V and U? What is the relation between the V and U? V and U relation I want to find out. You can conserve the mechanical energy because no external force is acting and no non-conservative force acting. And whatever be the tension is acting, tension force, the tension will do the zero work. Okay, na? So you can write down one more thing. Work done by tension is zero. Work done by tension force is zero. Because tension is always perpendicular to displacement. Tension is radial force. So tension always act along the radial direction, and radius is L. Okay. So then I can write down by conservation of mechanical energy. Conservation of mechanical energy. What I can write down? So now I'll take, this is the zero potential energy level. You can take zero potential energy level anywhere. So my suggestion is always take the zero potential energy at the bottommost point. You can fix to something and you can follow, no problem. So if I'm taking, this is the zero potential energy level, what the initial energy is? Only kinetic energy is equal to, what is the energy over here? Now it will have potential energy. There is height from the zero level. Okay, na? So what is the potential energy I can write down? mg into 2L. What is the height from zero level? 2L. Plus kinetic energy is half mv square. Kinetic energy is half mv square. Got it? Now I can make a one more equation, that is you can multiply the 2 and you can cancel the m, then it is u square is equal to, multiply the 2, it is 4gl plus v square. Now the question arises, so these are the two equations, one is centripetal force idea I wrote, second one is energy conservation. Remember, these are the two ideas you have to apply in vertical circular motion. As it is a circular motion, apply the centripetal force idea. As it is vertical circular motion, vertically moving, height is changing. As the height changes, speed also changes for the object. So then how to correlate the height and speed? You can correlate by using the conservation of mechanical energy. So idea 1, idea 2. Question can be anything. You have to apply these two things. So we will also solve the questions, you will understand. Huh? Okay, all of you understood these ideas or not? So all of you understood these two ideas? Any doubt in this? Let me know. No doubt, no? Okay. Now the question is, what is the minimum velocity we can project? See, if you project with more velocities, you project, suppose I'm projecting with 20 meter per second, it will complete in the vertical circle, suppose. So if you project with 25, it will complete. If you project with 30, it will complete. If you are increasing the velocity, it will complete the vertical circle. But I want to see that with what minimum speed it will complete the vertical circle. Getting my point? So what is the target? Target is our aim. What is the aim? Aim of this topic is what? What is the minimum value of u or minimum speed? Okay, no? Minimum value of u. Okay, so that it completes it completes a vertical circle. Understood? What is the minimum speed of minimum value of u, so that it is completing the vertical circle? This is our aim to find out. So that means I want to find out the u value minimum. If u value is minimum, can I say that 4gl, this is a fixed value, 4g constant, l also constant, this is a fixed value, then if u value is minimum, automatically v value will become minimum. If u minimum, v minimum. Am I right or not? If this is minimum value, this has to be minimum value. Simple. And because this is a fixed value, this does not change. Okay. So this is the one logical relation I got. I told you that logical relation. Why? This is the actual relation. As we are applying the logic of minimum, we are getting this is the logical relation. Got it? Next, I want to find out the v minimum value. For that, what I'm taking this equation, first equation. So I'll take the first equation. What the first equation is? T plus mg is equal to mv square by L. So if you observe carefully this equation, T value can be variable. T is varying. T value will vary as it is moving. T is a variable quantity. Mg is a fixed quantity. V also variable quantity. V value changes as U value changes. Okay, na? T value also changes. T value changes because of V value changes. Suppose if I keep, now this is a relation, no? I'm writing logical relation. So if I'm keeping the minimum speed in this expression, so which one value should be minimum? Tension value should be minimum. If this is minimum, this has to be minimum, because both are proportional. If tension is increasing, V has to increase. As V is decreasing, tension has to decrease. You can say anything, because the equation has to be valid. If on the right hand side values are increasing, then left hand side also values are also increases. Otherwise, then equation won't be balanced. Okay. All of you understood these logical relations? Yes or no? Clear? Once observe all mathematical relations, then we can conclude something. See, understanding this theory is very important. If you understood the theory, then only you can go for solving the questions comfortably. Otherwise, in every question you will find a doubt. If u minimum, I'm giving the minimum velocity to complete the vertical circle, then automatically v value minimum. As the v value is minimum, tension value will be minimum. So we cannot keep v minimum as 0. V should not be 0. V minimum square, no, square terms. So speed cannot be negative. What is the minimum value of speed? 0 only. Speed is a number. Minus will tell you direction. So speed cannot be 0. So V minimum cannot be 0. Why? Because if V minimum is 0, then definitely no circular motion, it will fall down. Okay, na? U minimum 0. There is no, what is it, meaningless. Minimum velocity is 0, means you are not giving velocity. If you are not giving velocity, it won't go in any path, like it won't move also. Okay, na? So U minimum should not be 0. So U minimum is not equal to 0, V minimum not equal to 0. Then which can be 0? T minimum can be 0. What is the minimum value of tension? Minimum value of tension can be 0. So here the tension can be 0. Why? Because even though tension is 0, mg is acting towards the center. So centripetal force is there here. Centripetal force is there. Because of this centripetal force, that object will go in a circular path. It will try to move in a circular path only. And once it is moving further, then again tension value will appear. Tension value won't be 0. Tension value will appear. Because of again tension and gravity, the object will go in a circular path, vertical circle. All of you understood the reason? I'm repeating once. Listen to me. See, at this place tension can be 0. At remaining places tension cannot be 0. See, if I'm taking this place, if tension is 0, then mg is acting in this way and velocity is in this way. Now velocity and mg not perpendicular to each other. Velocity and mg not perpendicular to each other. So that's why if tension is 0 here, it won't continue in the circular path. It will go in some parabolic path, which is projectile path. But here at the highest point, if tension is 0, even if tension is 0, still it will go in a circular path. Why? Because mg is acting towards the center, mg and velocity are perpendicular to each other. So then mg will provide the necessary centripetal force there. Means here mg is the friend for tension, here mg is not the friend for tension. So mg won't support circular motion here, but mg can support the circular motion here, because mg and velocity perpendicular. Here mg and velocity not perpendicular. So that's why if tension is 0 here at this place, it will leave the circular path. But here, even if tension is 0, it won't leave the circular path. It will follow in the circular path only. It will continue in the circular path even though you are taking the tension is 0 at the highest point. Hope you understood. Any doubt, let me know. Think about these 2 points. If you can compare these 2 points, you can understand. Here, take the tension is 0. Here, if you are taking the tension is 0, it won't continue in the circular path. Why? Because velocity and mg not perpendicular to each other. So that's why it will leave the circular path. But I can take tension is 0 at the highest point. Why? If I'm taking the tension is 0, tension is not there, let us say. Then mg is there, na? which is perpendicular to velocity, and mg is acting towards the center. As mg is acting towards the center and velocity is perpendicular, then it will continue in the circular path. It will try to move in circular path. Once the pendulum is crossed that position, then automatically tension will appear at some angle. At some angle, tension will appear. Because of tension and mg, again it will go in a vertical circle. Got it? Understood? So what is the minimum value of tension possible is 0. Got it clear? Understood? Clear all of you? Very good, Lokesh, ready. So then we'll get the relations now. Once you understood this, you can get the relation. As minimum tension is 0, then what is the minimum velocity I can write down? I can write down the minimum velocity. Just a minute, you can write down, don't worry. So as tension is 0, as minimum tension value is 0, mg is equal to m into v minimum square by L. See, that is the equation. Mg is equal to m into v minimum square by L. So then I can write down mm cancel out. So GL is equal to v minimum square. Okay, so then what is the v minimum value is equal to minimum velocity at the topmost point when tension is 0. This is the minimum velocity when tension is 0 at the highest point. Okay, obviously we are talking about highest point only. At the highest point. Once I know the v minimum, I can go for v minimum. Sorry, u minimum. What is the u minimum is? U minimum square is equal to 4gl plus v minimum square. U minimum square is equal to 4gl plus v minimum square. Okay, na? So then u minimum value we can find out now by 4gl plus what is the v minimum to complete the vertical circle? Minimum velocity is square is gl, so I'm writing directly gl, which is 5gl. So what is the minimum velocity required to complete the vertical circle? Root 5gl. That is the minimum velocity required to complete the vertical circle. That means if I am taking any pendulum, and this is what? This is a string. So I'm talking about string. String can become loose also. String is nothing but thread. So I'll discuss why I'm talking about string only. Okay. So what velocity should be given to complete the vertical circle? When velocity is greater than or equal root 5gl or root 5gr. L is nothing but radius. L is nothing but radius. You can keep it as root 5gr also. Then the object will complete vertical circle. Object will complete vertical circle. If u value is equal to root 5gl, then what is the tension at the highest point? 0. If you are increasing the velocity at the highest point will increase and tension value also will increase. Okay, na? So okay, I'm writing for u is equal to root 5gl. Okay, tension at highest point. Tension at highest point is equal to 0. Okay, na? For u value greater than root 5gl, what happens? Tension at highest point is greater than 0, and we'll see how to calculate it. Don't worry. Okay, na? Clear this part? If u value is less than root 5gl, then what happens? If u value is less than root 5gl, suppose I'm not giving the root 5gl, I'm giving the less than root 5gl. Less than root 5gl, first of all, it does not complete the vertical circle. So then there are 2 chances. One is for oscillation, it can oscillate, or else it can leave the vertical circle. It can leave the vertical circle or it can oscillate also. Okay, na? Write down this. I'll keep the first this one. You wrote down this thing, I think so, right? Wrote down this part. Completed? Comment. Okay, location already completed. What about others? Completed, Bhavana. Okay, good. So then you can start from here. Yes. Okay, Nazia. So now write down the complete condition for completing the vertical circle. From here you can write down. So tell me if you complete this page, I'll keep the other page. So all of you try to derive this thing on your own. Then you will understand better. Okay? Na? See, some topics in physics will be there. They will, they will become easy or they will become understandable when you are working on it. Okay? Na? So teacher give you will path, some path. So when you are working and when you are solving, when you are deriving those things, then you will feel more comfortable with the particular concept. If you are not deriving this, then definitely you will have a problem in solving the questions, no doubt. Okay. Previous came, this one. So one condition is finished. That is completing the vertical circular motion condition is finished. Now we have to see that conditions for leaving the circular path and oscillation. For oscillation and leaving the circular path conditions, we have to see. Chance to break the string. Yes, there is a chance, Lokesh Reddy, obviously. It becomes, as you're increasing the velocity, breaking the string chance will be there when you are giving the velocity more than root 5 what I feel. It depends on the string also. String will bear some maximum tension. Every string can bear some maximum tension. So you are giving the velocity in such a way that tension value is exceeding that value, then automatically it will break. Okay, good thinking, Lokesh Reddy. Nice. So tell me at which point there is a chance for more, more chance for breaking at which point of or which position of vertical circle. Lokesh Reddy, now think about at which position breaking of string can happen. Chances will be there, more chances. At what point of vertical circle there is a more chances for breaking of string. Lokesh Reddy, that is bottommost point. No, not 90. Bottommost point. At bottommost point. Why? Because at bottommost point tension is maximum. Maximum tension will act at bottommost point and minimum tension will act at highest point. Okay? Location ready, okay now? We'll discuss. In the questions also we'll discuss. You will understand. Yeah. You also once verify. Okay, Bhavana completed. Very good. Okay, this entire derivation you should be in a position to write yourself. Okay, all of you in the evening try for this derivation on your own. Take it some 10-15 minutes and try to derive the same thing on your own. Okay. Completed. Shall I keep the next slide? Okay, Nazia. School completed. Very good. What about others? Others also completed, right? Okay. So this is the next one. Okay, you finished this part also. Location ready. Good. Najia finished. Very good. Ajay switched off his video. Now he switched on the video. Adil, you wrote down your notebook or not? You copied this, huh? Okay. So completed, everyone? Okay, Adil. Switch on your video and keep it one place. Yeah. So what about others? Others completed? Still writing? We'll go for next part. What about school? School, everybody completed? Okay, good. Next, what we do is we will take one. We can write down one thing now. If u value is, what the u means? U means speed of the pendulum or speed of the bob at the lowest point, at the bottommost point, something like this. This is the u value. U value means this usually. Yeah. Okay. If u is less than root 5 gl, if I'm giving less than root 5 gl, if it is equal to root 5 gl or more than root 5 gl, then what will happen? It will complete the vertical circle. If it is less than root 5 gl, then what happens? If it is less than root 5 gl, then there are two choices. One, pendulum may oscillate. Pendulum may oscillate, or pendulum may leave the circular path. May leave the circular path. Okay, na? So there are two chances. So now we want to see that at particular what velocities pendulum will oscillate, at what velocities pendulum will leave the circular path. I want to see that what are the velocities less than root 5 gl. Okay, so for that what I'm doing is I'm taking the pendulum and of length L, which is nothing but radius. We are giving the u velocity, then it will go in a vertical circle and it will get some velocity v after rotating by an angle theta. Okay, na? So this is the zero potential energy level you can take. Okay, na? This is zero potential energy level. And what is the height? Height, it is gone. Height, it has gone h. Now it is going in the path of circle. So it will go in a path of circle only. Okay, na? If it's going in a path of circle, but just we have taken the one random position. I've taken some random position of angle theta. After rotating by an angle theta, then what happening? That I'm going to see. After rotated by an angle theta, so what is the speed of the pendulum? Speed of the pendulum or speed of the bob is v. Initial speed is u. And what is the height raised is h. Then what is the relation between the v and u? So first we can write down the relation between the v and u, no? That is by what? Conservation of mechanical energy. So by conservation of mechanical energy, what I can write down? I can write down that total energy at the bottom, which is half mu square, is equal to, now what is the potential energy? mgh plus kinetic energy half mv square. Okay, na? Mechanical energy is conserved. This is zero potential energy level, bottommost point, and this is the v speed, and height is h. So I can write out in this way. Now I can cancel them and I'll get the relation something like u square is equal to 2gh plus v square. Okay, na? So this is the one relation. This is the one relation. Now what I'm writing is, now I'll write on the forces concept. So I told you already, as it is going in a circular path, what are the forces acting? Some force should act towards the center. This is mg. Okay, na? So if I extend this line, this angle is theta, this angle also will be theta. Then what are the components I can write down? The components I can write down, mg cos theta is acting along the radial direction. Mg sin theta will act along the tangent. See, this is also important thing. Mg sin theta is the tangential force. As it is tangential force, so tangential acceleration will be mg sin theta by m. G sin theta will be tangential acceleration. See, velocity is in one direction, mg sin theta is in opposite direction. So I think you remember the non-uniform circular motion. If velocity and tangential acceleration are opposite to each other, what happens to speed? Speed will decrease. So that's why in this entire rightward journey, right half of the circle, speed decreases, whereas in the left half of the circle, speed increases. Okay, na? So you'll find both. You'll find there is an acceleration towards the center, there is an acceleration along the tangent. Means vertical circular motion is a non-uniform circular motion or uniform? We can say easily it's a non-uniform circular motion because speed is changing, no? Speed changes. As the height value changes, speed changes. So that's why vertical circular motion is a what? I mean, pendulum. Pendulum vertical circular motion is a non-uniform circular motion. Clear? When a pendulum is projected, it's a non-uniform circular motion, and this is a tangential acceleration. But we don't require this. We require the centripetal force. So what is the centripetal force I can write down? Tell me, what is the centripetal force? Tension is acting towards the center, but mg cos theta is acting away from the center. That's why centripetal force I can write down T minus mg cos theta. Understood why I'm writing minus? Because both are opposite. Force acting towards the center positive, force acting away from the center is negative or opposite. So net force acting towards the center, T minus mg cos theta, because T should be more. Then only it will go in a circular motion, no? Vertical circle, okay? Is equal to what I can write down? M into speed at that point, V square by radius. Radius is L. Speed at this point is V. That's why mv square by L I wrote. But I want to write down the tension in terms of height. Tension value I want to write down in terms of height. I got V value in terms of height, and tension value also I want to write down in terms of height. So for that, I can say that this is, can I say this length is L cos theta? See once. If you see this triangle, this is L, hypotenuse is L, this angle is theta. Then what the adjacent side is? L cos theta. And this is height H. This value is H. This value is H, and what this value is? This length is L cos theta from the center, okay? L cos theta, and this is H. L cos theta plus H should be equal to L. Okay, na? So L cos theta plus H should be equal to L. Then what is the cos theta value? Write down the cos theta, because here cos theta term is there. So what is the cos theta I can write down? L minus H by L. All of you okay? Or else you can do like this also. This is H. Then what this length will be? L minus H. And this is L. Then what the cos theta is? L minus H by L. That way also you can write down. Mathematics, no? You can do anyway. Your choice. So understood this cos theta. Now I want to find out the tension. So this is the equation. This is done. Huh? Now I'm changing this equation in terms of heights. So mg into L minus H by L is equal to m by L into V square. In the place of V square, I can write down U square minus 2gh. All of you okay? This thing? So everything now in terms of H only. Tension value. So T minus, this is T minus mg into 1 minus H by L. So, okay, na? So this is m by L into, or else we can leave it in this way only. We'll leave this part. We are not simplifying this. We are leaving, and further we simplify. Now the question is, I'm taking, see, this is the one equation and this is the second equation. Let us say, suppose, I'm supposing that, okay, na? At height h1, speed is 0. At a height h1, speed of the pendulum is 0. Speed of pendulum is 0. See, you will find some mathematical relations for some time. So just bear with me. Okay, na? So little mathematics is there. After mathematics, I'll explain what is happening. At h1 height, I'm taking that speed of pendulum is 0. h1 height, speed is 0. Let us say, that is my supposition. I'm assuming. I don't know whether it will happen or not. I'm assuming that at h1 height, speed is 0. So then I can use this equation. U square is equal, first equation you see once, this equation. U square is equal to 2g h1, height value h1 if I write, what is the speed value will become? 0. Speed value is 0 at h1 height. h1 height, speed is 0. So that's why speed value is 0, height value h1. Then what is the h1 value I can write down? h1 value is equal to u square by 2z. So it's something like in kinematics. If you project with velocity u, then what height velocity will be 0, speed will be 0, maximum height, no, which is u square by 2z. Okay, only thing that is vertically will go, it will go in a circular path. That's the difference. Similarly, I'm supposing one more thing. Suppose at height h2, tension in the string becomes 0. Tension in the string becomes 0. Understood? At what height tension is 0? At h2 height. So now we have an equation here. So if in the place of height, if I write h2, then what the tension value will become? Tension value will become 0. Getting my point? Understood? At height h2, suppose in the place of h, if I'm writing h2, then what the tension value has to be? 0, because that is our assumption. That is our supposition. Okay. So second equation will become, how the second equation will become? Tension value is 0 minus mg into L minus h2 by L. See once, in the place of height I'm writing h2 is equal to m by L into u square minus 2g h2. Just replace height value with, okay, replace height value with h2, then tension value you have to keep 0, then you will get the second equation. Now I can find out the H2 value. How to find out the H2 value is minus mg by L into L minus H2 is equal to m by L into u square minus 2g H2. Let us say m by L cancel out in both times, both the places. M by L cancelling out, and what is the value? This is minus g L plus g H2 is equal to, this is u square minus 2g H2. Okay, na? Now I want to find out the H2 value. Take the 2g H2 on this side. So 3g H2 is equal to u square plus gl, and H2 value is equal to u square plus gl by 3g. This is important expression. Try to remember. On this you may get questions. At what height the particle will leave the circular motion is, this is the height. Why? Because tension is zero. Tension is becoming zero at this height. At H2 height, tension is becoming zero. Means what? Leaving the circular path. Whenever they're asking the leaving the circular path, okay, leaving the circular path question, definitely that is related to this height. Okay, so this is the height. At this height, Bob will leave the circular path. Clear? Understanding this? So we got two heights. One is the height at which speed is zero. Second one is the height at which tension is zero. Clear? Now, what is the condition for oscillation? Tell me. Now you'll get it automatically. What is the condition for oscillation? Condition for oscillation is speed should be zero, but not tension. What is the condition for oscillation? Do you remember? First I explained. Speed should be zero, but tension should not be zero. Tension should not be zero. At what height tension is becoming zero? H2. At what height speed is becoming zero? H1. So this implies H1 should be less than H2. If H1 is less than H2, then which height first Bob will cross or pendulum will cross? As H1 is less than H2, pendulum will cross first H1 height. So once it is crossing the H1 height, then speed will become zero. Then automatically it has to come back. It cannot go to the H2 height. Understood? Imagine like two heights. This is H1 and this is H2. So pendulum will reach first what height? H1 height. Whenever, as soon as pendulum is coming to H1 height, what the speed will become? H1 height, not H2. H1 height. Speed will become zero. As speed is becoming zero, will it reach to H2 height? No. So it will come back again. So that means it never reach the H2 height. So tension value never be zero. You understood this logic? Got it clearer? H1 is less than H2. As H1 is less than H2, pendulum will reach first H1 height. At H1 height, speed is zero. That means it cannot go to the H2 height. No? It never go to H2 height. So it will go to H1 height and come back because speed is becoming zero at H1 height. So it never go to H2 height and never tension will become zero. So that is the condition for oscillation. Clear? Then H1 is less than H2. What is H1 is less than H2? U square by 2G. H1 is less than U square plus GL by 3G. Okay, na? So GG cancel out. So cross multiply 3U square less than 2U square plus 2GL. Then take the 2U square on this side. It is U square less than 2GL. Then what is the U value? Should be less than root 2GL. When U value is less than root 2GL, then pendulum will oscillate. Okay, na? This is the condition for initial velocity. Pendulum will oscillate. Okay, na? So now we can go for reverse is the condition. So I'll go for other condition. What is that? Condition for leaving the circular path. Condition for leaving circular path. Now tell me what is the condition for leaving the circular path? Now tension should be zero, but not velocity. Tension should be zero, but velocity should not be zero. Okay, so that means this happens when H2 is less than H1. H2 is less than H1. When H2 is less than H1, first which height it will go? Pendulum will go to H2 height. Okay, na? So that tension will become zero. So it will leave the circular path, then it cannot reach the H1 height. It cannot reach the H1 height. Okay, na? So that's why velocity never be zero. Logic you understood? Huh? Whichever is zero, that height should be less. Here tension has to be zero. What is the height at which tension is zero? H2 height. So that way H2 should be less than H1. So that is all other way to think also. Okay. H2. What is the H2 value is? H2 value is U square by, okay, and H1 is U square by 2z. Okay. U square plus GL by 3z is less than U square by 2z. Okay, na? Now cross multiply it. G cancel out. 2U square plus 2GL is less than 3U square. So 2GL is less than U square. So U square is greater than 2GL. U should be greater than root 2GL. So root 2GL is the boundary condition. Less than root 2GL, pendulum will oscillate. More than root 2GL, of course, U value should be less than root 5GL. We are talking about completely root 5GL, less than root 5GL only, na? If it is more than root 5GL, it will complete the vertical circle. So whenever this condition is valid, then pendulum will leave the circular path. Already I wrote above, will leave the circular path. All of you understood? So little logical, you have to think because it is logic. Okay, yeah, understood. So H1 I2, H1 H2 we calculated heights and then we applied the conditions. So I think from you are required to write down. All of you write down from here. So I'm thinking like I have explained a little faster maybe. I don't know how many of you understood. So don't worry, write down. We will discuss again tomorrow. Don't worry. First write down. Write down. You people also think about it. Then you will understand better than what I explained. You people think about it. Tomorrow I'll explain again. Okay, na? So I thought like I have explained a little faster. I don't know. If you understood, it's very good. Okay. Don't worry about this. I'll discuss again. But you people also once go through it. First write down and once verify after the class. So anyway, tomorrow is all day. Maybe I think so. Harisha told me tomorrow is all day. So as tomorrow is all day, you can work on this. So all of you go through the all derivations clearly. Okay. Revise all derivations. Condition for completing the vertical circle, even this. So at random place, these are the equations. One is conservation of mechanical energy, other one is centripetal force. See, whenever you are solving the vertical circular motion, remember only two ideas will work in the question, or two ideas you need to apply while solving the question. One is what? One is this centripetal force idea, other one is conservation of mechanical energy. Okay. Okay, Najay completed. Remaining people also completed. All of you understood this cos theta logic, L minus H by L. See the triangle and check L minus H by L. Okay. Okay, Bhavna, good. Completed? Shall I go for next slide? So anyone respond from school? Completed or not? Okay, just a minute. I'll keep the things. Yeah. Okay, I'll go for next slide. Yeah, this is the next slide. Till write down till H2 and you try for H1 H2 logics. Condition for oscillation and condition for leaving the circular path. Write down till here. Okay, na? Wrote down? Writing. So better to write down till H2, then try for H1 H2 relations. Condition for oscillation and condition for leaving the circular path. Location already completed. Okay. Write down till H2 height. Then you try on your own condition for oscillation and condition for leaving the circular path. Okay. So from school, anybody completed or not? Write down till H2 only. Huh? I will explain again this part. Don't worry. Okay, if you wrote down, you can leave, no problem. Already people are leaving. Okay, school completed. Very good. Remaining people also wrote down. Till write down till here, and you have to try for these things: condition for oscillation and condition for leaving the circular path, both. So that's why I'm not keeping the other slide. Okay, till H to I you have to write down, and you have to try on your own. Already you listen to me na conditions. You try your own on your own so that you will understand better. And tomorrow, I mean, not tomorrow. Next class, I'll discuss the things. Again, we'll discuss this part in the next class. I'll explain. Like, I'm not going to write down again, but I'll explain again. Okay? Yeah. So, all of you try for conditions of leaving the circular path and oscillation, and we'll discuss it in the coming class. Okay? Bye, everyone. Bye.